the sun and all its mesmerizing splendor. Our light, our life. It's a Greek god Helios, Egyptian god Ra, born every day. Everything we do, controlled by sun, depends on it. Our sun is 4.6 billion years old with diameter more than 200 times than Earth and mass 333,000 times of Earth. It is so big that it can fit more than million Earths. Though Sun is a hot star of incandescent gas, but it is a lot cooler on its surface than its core. The temperature at the core is staggering 15 million degrees and at the surface it is 5,500 degrees or so. In our solar system, the Sun carries around 99.85% of the total mass, which left us with significantly small amount of 0.135%. This is just in our solar system. If we compare with our own galaxy Milky Way, which is 100 billion times heavier than Sun, we are just imperceptible. When light is emitted from the core of Sun, it is bounced around inside for 200,000 years before released in space. But the distance between the Sun and Earth is so vast, the light emitted from the Sun takes 8 minutes and 20 seconds to reach Earth. If we decide to travel to Sun with a commercial aircraft, it will take 26 years to reach there. Most of you may not be familiar with the concept of galactic year. Basically, it is the time taken by our solar system to complete one orbit around the center of Milky Way. Now, the thing which speaks itself for the vastness of space is that the Sun is 26,000 light years away from the galactic center, and it travels at a speed of 220 km per second. It will take around 250 million Earth years for just one galactic year. Apart from heat and light, there are various phenomena going on the surface of the Sun, such as coronal mass ejection. CMEs are huge. These are the bursts of solar wind which releases huge quantities of matter and electromagnetic radiation into space above the Sun's surface. The ejected material is plasma consisting of primarily of electrons and protons. Most CMEs are ejected from the active and the cooler region on the surface of Sun known as sunspot. These particles usually take 24 to 36 hours to reach Earth. The smaller CME events hitting Earth shut down satellites and global communication systems. Also, it changes trajectory of aircraft and interrupt electric power grids. But when a massive CME that directly hits Earth, it can be exponentially more dangerous and could severely damage and wipe out anything electric. On September 1, 1859, astronomer Richard Carrington noticed sudden explosion of light coming out of the cluster of sunspot from a CME. It is also known as the Carrington Event. The CME was so intense that the Earth was bombarded with EMPs. At that time, the technology in the world was at the threshold and hardly sensitive to electromagnetic disturbances, so we didn't see any significant change. But still, it did take down the parts of recently created telegraph network, starting fires and shocking some telegraph operators. Also, auroras were seen across the globe. On July 23, 2012, similar CME event of intensity as much as Carrington Event or more was recorded from the surface of the Sun, and it directly passed through the Earth's orbit. But fortunately, Earth was not there. But it did hit the NASA's Stereo A probe, without which we would have never found the intensity of that superstorm. If Earth was there, it would have caused a catastrophic disaster, fracturing the structure of electrical networks. When we are so deeply dependent on electricity, modern technology and telecommunication device. We were so lucky during this event that if the same event would have happened a week earlier, it would have hit the Earth, resulting into inevitable disaster. And we would have been still recovering from the pieces. Solar storms and space weather can adversely affect our technology in space and on Earth. So, to find out the source of coronal heating, which has been a scientific mystery for more than 50 years, we have launched various observatories monitoring the Sun 24/7. Observatories such as SOHO and TRACE has given us solution. Still, the complete answer was not there. Later, Stereo and STO Observatory has improved our knowledge of corona to a great extent and also gives us precise space weather reports. The Sun is the biggest star in our solar system, so it emits huge amount of energy. The Sun's output energy every second is about 500 sextillion horsepower. That's a quite big number. In other words, in 1 second, our Sun produces enough energy for almost 500,000 years of the current needs of our so-called civilization. You need to explode 100 billion tons of dynamite to match the energy produced by Sun in just 1 second. Voyager 1 was a space probe launched in September 1977. Its primary mission was the exploration of Jupiter and Saturn. After making a string of discoveries, such as active volcanoes on Jupiter's moon and intricacies of Saturn's ring, the mission was extended to Voyager interstellar mission. Even though it has been over 35 years since Voyager spacecraft is launched, it is still within our Sun's sphere of influence. In August 2012, Voyager 1 made the historic entry into interstellar space, leaving the heliopause, which is the theoretical boundary where the Sun's solar wind is stopped by interstellar medium. To this day, Voyager 1 has traveled a distance of 20 billion kilometers, which is equal to almost 1 light day, which shows us the enormousness of space. Sun is about halfway through its life. Over the course of past 4.6 billion years, during which planet Earth and the entire solar system was born, it has remained relatively unchanged. This will stay for another 4 to 5 billion years. The moment it will exhaust all its hydrogen supply, some pretty drastic changes will take place. When the Sun will start to die, it will swell so big that its surface will extend to the orbit of Earth and will engulf Earth. In short, we have about 4 to 5 billion years to find a new home, where life can flourish like on Earth. A recent discovery has found Earth-like planets like Kepler 452b, which has more chances of having suitable conditions for life to emerge.